Number 10 from the book, you have a live viewer plot here, and the questions give you the intercept for both axes. The y-axis, you have the y-intercept at 2, and then x-axis, you have -4 as the x-intercept. So the questions ask you to calculate the value of Vmax and Km. So Vmax would be y-intercept, but this point is actually equal to 1 over Vmax, and then x-intercept is actually -1 over Km. So you need to calculate the value of Vmax and Km. So to begin with, general idea for this graph is that this value has been modified by the factor, and you can see here that your y-axis have been modified by the factor of 10 to the 2, and then your x-axis is modified by the factor 10 to the -4. So in order to get into the actual value, you need to take this factor into account. So first, so if you have 1 over Vmax equal to, and as I mentioned earlier, that 2 is not the actual value. You have to convert it back to the actual value by using the factor that has modified the number here. So the y-axis has been modified by 10 to the 2. So the actual number, it would be 10 to -2, because if you have, let's imagine that if you have 2 times by 10 to the -2, and then you want to get rid out of this factor, this modifier 10 to the -2. So that's why you say that, well, one thing that we can do is that we use 10 to the 2 to times by the actual value, and then use this factor and indicate it in the axis. So when you use 10 to the 2 to modify your value, that's why you can cross this out, and then you can just plot the number 2 over here in the graph. So using a factor to modify the axis would make your graph look simpler, and that is the objective of why we need to get into the actual value. Because if you don't use the factor to get into the actual value, the calculation for Vmax or Km would be inaccurate. So getting back to our 1 over Vmax here, 1 over Vmax would equal 2 times by 10 to the -2. And the unit would be the unit that's specified in the axis. So you need to solve for Vmax, and that would mean 1 over 2 times by 10 to the -2. And then the unit right here would be nanomole per liter per minute. Right? Because in the axis, you say that this has been like to the -1. So when you flip it over, this -1 is getting rid of. Okay, so to Vmax here, then you can solve for Vmax, and you get 0.5 times by 10 to the 2 nanomole per liter per minute. Or your Vmax is equal 50 nanomoles per liter per minute. You can write the unit this way or this way. That's acceptable. So again, these kind of questions, just make sure that you include the unit every time that you calculate it, because it's can be confusing. So don't forget to put your unit in your calculations. Okay, so that is Vmax. And getting to km. So from the graph, we see that minus 1 over km equal minus 4, but it's not actually minus 4, right? You have to take the factor from the axis to modify it back to the real value. So minus 1 over km would equal to minus 4 times by 10 to the 4th, right? So you just flip 10 to the negative 4 into 10 to the 4 here. And then if you move km to this side and then moving this term into this side, you would get km equal minus 1 divided by minus 4 times 10 to the 4. And the unit for km, because it's molar to the negative 1, so right now you would get the unit of molar because you just flip it all over, right? So now km would equal 0.25 times by 10 to the negative 4 molar here, correct? And or 2.5 times by 10 to the negative 5 molar. Following so far how you change it back to the real value here. And that's how you solve for km and Vmax for the line Beaver plot.